Okay, so let's get started with today's stuff.
Yes, sir.
So what are we doing today?
The same thing, sir. Classification only, another model.
Right. So yesterday we did, which model did we do yesterday?
Ads, sir. Three startup model.
We did logistic regression, isn't it?
Yes, sir. Logistic regression. Yes, sir.
Right?
Yes.
Let me copy the code again.
Okay.
Okay. So logistic regression is done. So what happens in logistic regression? How does it work?
The same thing, sir. First, we will call the model. I mean, then train the algorithm. After that, we'll form the confusion matrix. In classification part, we'll form the confusion matrix, and then based on the values, we'll check for different parameters.
Right.
Yes, sir.
Okay. And here you have a, 50%, less than 50%. You can change this value, of course.
Yeah.
Less than 50%, we say it is less than 50%.
Zero.
We mark as 0, right? Like no. And more than 50%, we mark as 1. Right? So that's
actually, that part where did we do, sir? I didn't get
no,
it.
we did not do. Logistic regression by itself will take 50% here.
Okay, by default.
So,
okay.
yes. Okay. So again, let's go and see different parameters that it has.
Okay.
One second. Okay. So you say logistic regression, sklearn, right? So it will take you to sklearn, scikit-learn dot linear model. Okay. Now here there are different parameters that it takes. Okay, it takes L1, L2, elastic net, none. So okay. Okay, so these are different parameters that are there, but it all has its default parameters as well.
Yeah.
Okay, so if you have to add penalty, okay, so default is when we don't give, it takes L2 as penalty. Okay.
Yes, sir.
Then you have dual. So you can use it if you are using L2 as penalty. Then this is your tolerance. Okay, by default it is 1 e minus 4 means 0.001. Okay, this C, okay, for regularization, then fit intercept. By default it is true. You can say false as well. Okay, so intercept scaling, these are all different values here. Then you have class weight. Okay, so if you have multiple input parameter, right, should all be treated equally, right? That's what weight says. So if you do not give, then everything will be treated equally, all the features. Then of course random state you have solver. Okay, which solver? So by default it uses LBFGS. You can change if you want to use elastic net. If the X values are less, you can use elastic net here, Saga. Okay, then how many iterations? Default 100. Okay, you can choose if it is multi-class. Default it is binary class. Okay, And okay, this is ratio for elastic net. Then attributes that it will have, okay, which you can print output. So it'll tell you the classes. If you want to print regressor.classes, it'll tell you what all class labels it has taken. Okay, coefficient value, intercept value, number of features that it has taken. Okay, so these are different values that it takes. Okay.
Yes, sir.
But what we can do is, we can simply take, default one better. Okay. So default one, it takes default values. Okay. So that's what, we took default and it took default values. When you don't understand, take default values. Okay. So this is how logic regression. So logic regression is trying to, it will use sigmoid function to convert the input parameters into, or what you call the regression line into class. Okay. Okay. Now we'll talk about SVM. Okay. What does SVM do?
It will calculate the distances of the.
So right now here, see, in classification, it will find the maximum distance between two different classes. Okay. So so this is for regression, right? I'll comment this regression. Okay. Now I'm going to say this is there in it, you have it in SVM, isn't it? So from sklearn dot SVM, okay, import SVC. Okay, sorry, so capital SVC. Okay, that's what it's giving, right? Okay. Now classifier equal to SVC. C for classification. Now you can give your kernel. If you give kernel as linear, it will perform same like a logistic regression.
Okay.
Okay. So linear will not take any other value. So you can run this and you will get the accuracy for both training data and test data. Okay. So accuracy of test is 0.8 and training is 0.8. Okay. More or less, it should be in same range. So it looks good. Now you can change it to your RBF. Now when you change to RBF, okay, it has gamma, okay, and it has C value.
Yeah.
Okay. So if you see here, accuracy has increased, isn't it? In logic, we had accuracy of 0.83. Here you have 0.92.
Okay.
Right? Of course, SVM is doing better work than linear model.
Yes, sir.
Okay, if I increase gamma and if I decrease C, okay, it has decreased. See, the answer has decreased. So that means definitely it should be higher value in this case. Now, if I take 1, this is what you have to do. It has decreased, right? So this is what you have to do when you are running your models. You have to put it in the for loop. Okay. Now see here, it is 91, but here test is 88. Okay. Now if you see here, it has gone down. isn't it?
Yeah.
So what we had earlier was better. And then what happens when we increase C? Both should increase or decrease. If one is increasing, other decreasing, then that's a problem here. You see? So probably this looks the better solution for your gamma and C value. Make sense?
Yes, sir.
So no. Um, I just said again, in support vector machine, okay, so you have, okay, so it will take the training set, plot the graph, and look for, okay, RBF will look for curve, okay, what is the best curve, right? And okay, the curve that gives the maximum space. These are called support vectors, okay, on which this plane will lie, the nearest point. Okay, so let's say if these both are, okay, this is near, this is probably not near, right? So this is your support vector points. Okay, so in SVM you're trying to find, in SVM classification, SVC, support vector classification, you're trying to find maximum gap between two different given data, trained data. Once you have, then you create this line, okay, or curve, okay. Now if you have to ask a new value to classify, it will check, where this point lies with respect to this line. If it lies below, it'll classify as this value, set of this, here, set of this, okay. So this is your SVM or SVC rather, okay, support vector machine classifier. Then we have decision tree, okay. In decision tree, okay, so this is your SVM, right? Now we'll talk about decision tree logistic, and I want you to write the code now, okay, for the plotting. We can see how it changes for SVM, decision tree, and logistic regression, okay.
Okay.
So here you will say from sklearn.tree, okay, import decision tree classifier, right? And your classifier equal to classifier dot fit, right? First you have to do fit. So anyway, it is done. So classifier equal to decision tree classifier. And one parameter that it takes is called criterion. Criterion, and here you say entropy. Now, you can have, okay, entropy. Okay. Now let's check this. Okay, sklearn dot tree dot decision tree classifier dot html. Let's better, let's search here. Okay, decision tree regressor, decision tree classifier. Okay, so here you have Gini index, entropy, and log loss. Okay, it's a function to measure the quality of split. Okay, so Gini, okay, so Gini is used for impurity purpose, okay, and log loss and entropy for both channel information. Now, for how to calculate Gini index, I'm going to tell you, okay. Um, um, uh, maybe you can do it right now itself. So see, as I told you, right, decision tree is used to create that decision at every stage, isn't it? Now, how do you create the decision at every stage? What criteria is used? Okay, what criteria is used? So one of the criteria that is used is called Gini index. Okay, so um, okay, so let's say um, you have training data, isn't it? So training data for decision tree. Okay, so let's say it has created some kind of decision trees. Okay, okay, let's say these are the decisions it has created. Now, for each of these, it will calculate Gini index. Gini index is your uh, how many. Okay, so for example, at it, so let's say if this is your criteria decision, right? So how many of them have been wrongly classified on both the side? Okay, so it measures. Okay, so let's say in this there are three values which are correctly classified, but one value which is wrongly classified. Okay, let's mark it cross. Here it should be cross. Okay, but there is one circle here which should have been here. So total your index is 3 plus 3 is 6, right? 6 out of 8. This is your Gini index. Okay, and for every decision it actually calculates Gini index. Okay, so the one that gives minimum, or sorry, maximum Gini index, right? That decision is taken into account. Okay, it has to make decision somewhere, isn't it? So every stage it takes the Gini index. If I make this decision here, how much error I'm going to get? If I move here, okay, then what is the error? If I move here, then what is the error? So okay, so it calculates. Okay, now similarly for uh, if you want to use, let's say, what's the accuracy here? Did we run this? Right? Now if I say Gini, okay, see 99% accuracy for training, but for test it is 82 only. So this is your, what can you say about this analysis?
Overfitting. Overfitting.
Oh, it is overfitting.
Yeah.
Okay, it is overfitting because that's what. So Gini index, because for training data it knows, right, where to create, but the test data could be totally different,
Yeah.
right? So that's why so you have to first Gini, then it's the entropy, and then you see which one is giving you better result. So in this case here, okay, both, there is no change here, right? Or slightly this has become less.
So gene is better compared to entropy.
Gini is better, yes. Now, but again, I told you, right? Decision tree is a weaker
Yeah.
algorithm, right? So that's why we have random forest.
Yeah.
Okay, because if you expect these kind of things in decision tree.
Okay.
Okay,
Yes, sir.
so now I'm going to share this code. I
Yes.
want you to practice. Show me the graph.
Yes, sir. Same error I got yesterday also like this. X has two
This
features.
is it.
56, sir.
Go to 56.
Yeah.
Which one are you plotting?
SVC, sir.
SVC, right? So
Yeah.
you are you have contour x1. What is x1, x2? Okay, x1, x2 is x.
Mesh
Okay.
grid.
So yeah. So I'm saying that. So that is x set and y set. Okay, so you have taken x set as training and y set as train. Correct?
Yes, sir.
So if you are doing train, okay, uh, okay, error it says 56 reshape.
Yesterday I tried to change these columns also, maybe where I have done mistake, but I was not able to work out the same thing for logic regression.
So you have x1, x2. Then see classifier go up,
1 second.
slowly go up. Which classifier are you using here? Hold on. Okay, go up. So see, you're saying decision tree and you are using classifier as SVs. Comment this, no? Uncomment SVC. You're using classifier.predict, isn't it? So you're using classifier, yes. That is enough.
Okay.
No,
Anyway,
not like this. SVC you want to try, right? So uncomment SVC 29. 29 you uncomment and that 31 you comment. Okay. Yes. That is okay. Fit is okay. Fine. No problem. Uncomment 32. Otherwise prediction will go wrong. No.
yeah, yes, sir.
Uncomment 32. Yes. Now you run it. Okay. Come to scroll down to 56. Okay. So 56 onto classifier dot predict. Okay. And you are saying NP array x1 and x2 values. That is fine. And then you transpose, then you do the reshape. And C map equal to tested and you are seeing red green. So that what is coming. It says X has two features, but SVC is
What does he mean by X here, sir?
X means that 54 that you are doing. 54 is wrong.
Here we have X1 and X2, no, sir.
Right. So that's the X.
So X1 is the X.
We are going from minimum minus 1 to X equal to X at 0. Okay. Uh, Max plus 1. And you want to create at the step of 0.0.
Yeah.
Correct. Down you're saying 0, 1. Okay. Second value. So also correct. Wait. This is X has two features. X has two features. X has two features. Two features. Three features. Why X has two? X has two features. No. See, your input has three variable, isn't it? So you have to add one more to it. X3 also you have to add. Okay.
Yes,
Now
sir.
wait. Hold on.
Yeah.
See how many input values we have. How many feature we have? Three features. Correct. You have three features. Do you know what it says?
Yeah, I didn't get it, sir. We are dealing with 5 ad success data set now, sir.
Hold on. Listen to me
Yeah.
first.
Yeah.
Listen. Don't try to think ahead.
Okay.
You have already created the classifier,
Okay.
right? So you are taking the classifier which you have already created. Go up, scroll up. Okay. So where's your classifier? SVC, correct?
Yeah.
And when you say classifier dot fit, you are saying X train, Y train,
Hmm.
32.
Yeah.
Okay. Oh, how many columns are there in X train?
Checking that, sir. 1 second.
You can see line number 7. How many columns are there? One column 4. How many columns will you get?
5. 0, 1, 2, 3. There,
One
okay.
colon
We have
4
considered
is
only,
1, 2,
yes, 1 to
3.
3. Yeah, yeah. Here, out of the data set, we are taking 3. Yes, sir.
Yes, and 3, and the first one is gender, male and female. So
Yeah, yeah.
3 became 4. And in line number 15, we are ignoring 1. So you
Yes.
end up with three columns. So when you do classified.fit, it is taking 3 input. But when you're predicting only on 2, right?
Okay.
So that's the error. Now we cannot print all the 3 values, correct? For
Yeah.
demonstration purpose, go to line number 15.
15. Okay.
For demonstration purpose, first we will take 2 values at one go. Okay. So
Yeah.
in X equal to, you say 2 colon. If you say 2 colon, your gender is removed, another 2 is there. Now you run it.
Okay. Yes, sir.
Now what it says? Line number 60.
Yeah.
Check what is there in line number 60.
Going there, sir.
Line number 60, it says for
Boolean index did not match indexed array along dimension 0.
so are you using train or test here? Okay. So contour, so we have said reshape x1, fine. Okay, plot lim, that is done. Now here you are saying y set and plot scatter plot, fine. And we are saying x set where y set equal to j comma 0 and x set equal to j comma 1. So y set equal to x set. Okay.
Yesterday,
And then
I copied this, sir, but I didn't
color
understand.
equal to district color of I, and the label we want to display is j. So it says Boolean index did not match indexed array. Boolean index dimension is but corresponding Boolean dimension is 400. Okay, so we have used 25% there, right?
Yeah.
So that is the problem here. So we are trying to go up a little bit.
Yes, sir.
I want to see dimension is 300, but corresponding Boolean dimension is from where is getting 400 somewhere.
If it is considering complete set, then it can be 400, sir, because the set
That's what I'm saying. But how does it come to know there is a 400 here? That's what except
go
scroll.
up still.
No. Wait, hold on. So X train and Y train we have done, right?
Yeah.
Okay. Scroll down.
Yeah.
I
Yes.
want to go see that relation part. Relation part. How does it come to know there are 400? Yeah, hold on.
Yeah.
Matplotlib listed color X set and Y set is X train, Y train. X train and Y train both will get. Are you using X anywhere?
No.
X or Y?
No, sir. I just copied the same code you have done.
I could have done for 400. No.
Okay. Yeah. Hmm. Shall I go up and check, sir, once?
Oh, wait. X. See, we are only taking classifier from there. And X1 dot accept is X train, Y train. So it should not know there are 400 values. Thing is wrong there. Where it has gone to. For I comma j unique NP unique Y set. P unique Y set.
X train is 300 rows, Y train is also 300 rows.
Where it says Boolean index I.
What does this do, sir?
It will take only the unique value. Enumerate will break it into row and value. So see, when you don't understand, you can just print that portion and see. Okay, enumerate will break. We did that, right? It will tell you 0 comma first value, 1 comma second value, 2 comma second value. So I will be the index number 0, 1, 2, 3, 4, so on. And J will be the actual value.
Okay.
So because now I understand, okay, because we are saying why, right? Because it will take value from anywhere, right? So you might have 400 also, 300 also. See, it's not going to, so when you break into training set and test set, it is not going to take entire like 1 to 300 only, right? So
Yeah, randomly.
yeah, so it has the the position has 400 also. That's why it's saying 400. Okay. So now what we could do is, okay. So to visualize, just go and change that percentage to 0%. Okay. So one option is that. Second option is you create a new row with just these values. So go up the train test split. Okay. And you make it 0%. Yeah, 0.0. Okay. Now run. So because when we had y, right, there will be this side should not be, yeah. So do one thing here, comment that line, comment line 23 for this case. Okay. Or hold on. Uncomment. Let's not do this.
Yeah.
Go down where you are
What
doing.
will change
No,
this
no,
list
no,
size?
no, no, no. Yeah, make it 25. Make it 25. When you are plotting, right, instead of taking X train and Y train, let's take the entire data. So go
Okay.
down where we are saying X1 53 line number. Okay. Instead of saying X set equal to X train, just say X. Okay. And Y set equal to Y. Okay, now you run it. Okay, so because when you are doing the split, right, the index number, right? Remember, pandas will have index number, or rows will have index number. So that
Yes.
index number will be same, right? So if
Yes.
definitely when you're taking 25%, it's not going to take first 35 75% as training and last 25%. Okay, so the index will be 400 also there, and that's why when you enumerate, you're getting index as 400, but value is only 300 values are there. That's
Okay.
why it's creating problem. Okay.
Okay.
Or second thing could be, what happened is
Nothing, nothing.
graph. No, graph is still populating. And graph has come. I don't see the graph.
Okay, I'll show, sir. Sorry. It has come long back, sir.
Okay. So one option is that, yeah.
Can you see it, sir?
Yes, yes, yes. So you see this, it
Yeah.
is the shape of that, the middle path, right?
Yeah.
Is coming from your gamma and C value. Okay.
Okay.
Gamma, first you put this in a loop and you see how the shape changes. Okay. First you put C constant and see the gamma.
Okay.
C 0 and see how gamma is changing. And then you increase C also by 10, 20. And you
Yeah.
can see how the shape changes.
Yeah. That is what you have got different set of graphs here.
Right,
Yes.
right. So you have to use for loop and plot mini graph.
Okay.
Or second way here is, instead of doing enumerate, okay, you somehow take only y set value, don't say enumerate, and I you give 1 to 300,
So
right?
before that, I actually didn't understand what happened here. Yesterday also blankly I tried to copy the
Okay, tell me what is happening.
uh, now what have we have taken x set and y set as x and y. Okay, x is
Okay,
assigned to x set and all. And
okay,
I think this is the syntax of mesh grid.
correct.
Okay, what is this mesh grid, sir?
Mesh grid is your graph.
Okay,
The background that you see,
okay,
right? That's the graph, okay?
okay,
The graph. So we are plotting this graph, okay? The
yeah,
back end, not the the line that you see, the contour, that's contour line.
okay,
Okay.
okay,
So it takes that, it plots your graph. We are setting, so in NP range, we are setting the minimum and maximum value. Okay. We are
yeah,
setting the minimum and maximum value. So
okay,
it is like plotting a graph and then giving our x-axis and y-axis.
okay.
So I'm saying that whatever is the
These
minimum,
values -2, -1, 0.
because we have done standard scalar, right?
Yeah, 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 yes,
So
sir.
standard scalar has done. And
Okay,
what we are saying is on x-axis and then y-axis. First is your x-axis, second is y-axis.
okay. X2 is for y.
Yes.
Okay,
No,
okay,
no, no. Mesh grid has two values, right?
yeah,
Mesh grid, okay. First line and second line. 54 and
yeah. 54 only,
54.
54 only x1. This first part, sir. Second is
Correct. Correct.
x2. Nothing but y axis.
Correct. Correct. Y-axis.
Okay, yeah.
So we are saying that x set, okay.
Okay.
Now your x set and you have, no, is it, where's y set here?
Except 0, like age, maybe age is taken.
No, 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 no. So both are x, no. The features are both x, right?
Yeah,
And when you say comma 0, that means first row. We have two rows, isn't it? No, we just
column, sir.
two columns. Yes, columns. Sorry,
Yeah,
two columns, right?
yeah,
So your first column is on x-axis,
yeah,
second column is on your y-axis,
yeah. That's what.
right?
Yes,
So
yes.
yes, that's the y. So we are taking all rows, first column, and seeing the minimum value of it. So let's say if minimum value that is there is say -2, then you say -2 -1. You know, we want to be little safe.
Yeah,
So
yeah.
whatever is the minimum value, we are doing 1 minus. From there, what is the maximum value? Plus 1.
Yeah.
Okay.
Yes.
And the step means, so when you plot the graph, right? So mesh is what? It's running X and Y axis. You know, when you
Okay.
look at a chart paper, right? You will
Yes.
see those
Small
lines,
boxes.
small
Yes.
at millimeter that will do,
Yeah, yeah,
right?
yeah. Yes, sir.
So we are saying draw that line at
Okay.
0.01.
Here that is not visible for us.
Because it is 0.01, it's not visible.
Okay.
0.01 means in one, you'll have 100 lines. In
Yes.
1 centimeter, you'll have 100 lines.
Yes, sir.
So in 1 centimeter, if you have 100 lines, it
Yeah.
will look to you as if it's a colored paper only,
Yeah, yeah, yeah. Exactly. I
right?
understood.
If you make it 0.1, you can see the difference. If you make 1, you can see the difference. Okay.
Okay.
The purposely we are using mesh grid and giving a 0.01. Now 0.001 will be too much, okay, and it
Yeah.
will take long time. So
Okay.
0.01 will paint it like, it's very thin mesh.
Yeah.
Basically,
Big paint.
you'll
Yeah.
you'll feel as if there is no line. It's a color paper.
Okay.
Okay, if you give lesser value, of course the gap will be more between that. So
Okay.
first line is to look at the minimum and maximum value and draw the mesh. Second line again, minimum and maximum value of second column.
On the
That's
white.
why,
Yeah. Yeah.
yes,
Yes, sir.
yeah, that's why we have said except comma, colon, colon for all rows, comma 1.
Yeah. Yeah.
1 means we are looking at first column
Yes, sir.
because it is a two-dimensional, right? So that's why we have to use only two values. So we are checking which two to use. Okay.
Yeah.
Now here itself you can change. Here you don't have to change it. Here itself you can say x of 1 colon, all rows, comma 1 colon. So your algorithm will not get affected. Only the plotting will get impacted.
Yeah.
Okay. So that is the plotting the mesh grid and the graph paper like. Contour is the line. Okay. We call contour because it's not a line. It can be a curve, right?
One, sir. Yeah.
Yeah. So line number 56.
Okay.
So line 56. Okay. So x1 and y1. So we are taking x1 value and y1 value.
Sir, now are
Which,
you able to see my graph on the screen?
yeah, I can see your
Yeah.
graph.
Okay. Yeah. Yes, sir.
Okay. So x1 and y1 are, how many values are there in x1, y1? x1 and x2?
X1 and X2. X1 like 300. No, all the rows. 400 rows.
No.
Sir, exit we have assigned to X. No, sir.
No, that's what I'm saying. Here, okay, in x2 and x1, you have x1 and x2 will have all the points on x-axis, which is 0.01, 0.001, 0.002, 0.003, up to 3. It has thousands, not thousands. At least 300, 400 points it has.
Okay.
Okay, see, x and y, x1 and x2 is the lines that you have drawn on x-axis and y-axis.
Okay.
Okay, the point that we are drawing is the enumerate, that bubbles you see, right?
Yeah, yeah, yeah.
The green and red bubbles.
Yeah, yeah.
So green and red bubbles are your values from x-axis, sorry, from your data set. But x1 and x2 are the lines,
Okay.
mesh grid lines. So first what we are doing is, okay, first we are predicting for each of those points. See, okay, can you give me the control?
Yes, sir. I'm stopping the share. I did it, sir.
Yes. Let me share my screen. Okay, so we are taking x-axis and y-axis. Okay, now your x1 and y1 are all these values. At gap of 0.001.
Okay, okay, okay.
Okay, many points, right?
Yeah.
Also many points. Now on the contour, we are predicting. If you go contour, we are using classify.predict for each of x1 and x2. So what happens is we are predicting x1 and x2. So it is predicting green, 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 red, red, green, green, red, red, green, green, red, red. So to us looks like as if this is all green and this is all red, for example. This is all red, this is all red, and this is all green. Okay. In fact, it is predicting each of the points. Okay, so if you have -3 to +3, 6 into 0.01. Okay, so 600 points it is predicting.
Okay.
You are predicting 600 points, and that's how you get red and green. And that's why you see there's a counter. Counter is created because of the prediction that we're doing. Counter is created based on the prediction. We're predicting each of the points. Okay.
Yes.
Now in the for loop, so this is prediction based on the training.
Yeah.
So this is the training. Now how well have you done? So now the for loop, I'm taking each point and plotting here. So red is plotted red, green is plotted green on the map. So the points which are wrongly classified are the green points in the red zone and the red points in the green zone.
Okay. Okay.
Those are the wrongly classified values.
Okay.
Understand?
Ah,
So
yes,
first,
sir.
because first to get that entire plot, entire graph, I need to know how do you get, you have to predict for all the things. And that prediction will give you, red prediction or green prediction.
All the things in the sense, like remaining columns.
Rows and column, no prediction is done on 2 point, right?
Yeah.
It takes 2 values. That's why earlier we got that error because we have trained using 3 columns, and now you are predicting in that counter, you are predicting using 2 values only.
Okay, done, sir. Yeah.
Right? So you say that you trained me using 3 columns, but now how can I predict using 2 columns?
Okay.
Right? So
Yes.
that's why we went back and we changed.
Okay. Yeah.
Okay?
Understood. Yes, sir.
So you will get, so that color is formed. Okay, color is formed.
Yeah.
Based on that. Okay. So that's how you are first plotting and you're getting the color, different color. Now using for loop, you are pointing the actual values from the
Y set unique plot.
yes.
Okay. Y set is just 0 or 1.
Yes.
So the unique values will be 0 or 1. Or use 0 and only 1, no, sir. 2 values.
Yes.
Now, if we are enumerating it, this 0 and 1. What is?
Share your screen.
Yeah.
Okay. So y is your what prediction predicted value, right?
Yeah.
Y is your y set is your y train basically, right?
Output. Yes, sir. Not Y train, sir. Here.
It is Y train because everything is Y training. You have taken entire thing, right?
Yeah.
So Y, so it will take Y value and the index. Index will be 0, 1, 2, 3, 4, 5, 6, isn't it?
Yeah.
And you are taking Y. Okay. And now what you are saying is scatter X set. Okay. So X set means what? So see, Y is giving us the Y value, Y set, and we are saying that in X set, we want Y set equal to J. J means value. Okay. And then on 0. So see, you have X set as 0 and 1. That means you want, how do you represent a point on scatter plot? X comma Y.
Yeah.
All right.
Yes, sir.
So column 0 represents the value on x-axis and column 1 represents value on y-axis.
Yes.
That's why you see comma 0, comma 1.
Okay.
But which point to pick from there? Because you have many x, right? You have 400x.
Okay.
So which point on x and y you want? So it says where the value is equal to corresponding y set value. On x-axis, corresponding y set value we want. So index we are getting, right? So index 0. So now you are index 0 from X set of 0 and index 0 from Y set of 0.
Okay.
Okay. See, you want to plot. Okay. Again, give me my screen and take
Yeah.
control.
Yes, sir. Done, sir.
Yeah. So I want to plot. Okay. So here you have X0, X1, and your Y. Right. So you have 400 values, right?
Yeah.
So I want to plot, let's say, so Y, okay, we are iterating through Y, isn't it? We are iterating through Y.
Yeah.
So let's say Y takes this value first. Let's say it will take here 0, but let's say it takes this value.
Okay.
So what we are saying is, I need to plot from X0 and Y0. On X-axis, it is 0, 0, and 1, right? It could be any point here, right? Any point here, right? See, how do you know that I need X0 and I need X1? But which X0, which X1? Where this index is same as this index. That's why we are saying equal to J.
Okay.
Okay. See, this will not match. 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 Not match. Only this one will match, isn't it?
Yeah. Yes,
So
sir.
for this value, we are taking matching, and then we are saying, okay, on X1 value this and X2 this value should be plotted like this.
Okay.
So it is taking value from Y, but I need to find a corresponding value from X also, no?
Yeah. Yes, sir.
That's why I'm checking that condition.
Okay.
If it is true, then only you plot. If it is false, then don't plot.
Okay. Got it, sir. And the label equals to J.
Label equal to J is the value, right? That's the label. So
0 and 1. Yes.
0 and 1.
Yeah.
Right? So because that will decide your color.
Yeah. Okay.
Right?
Yes, sir.
That's why we had I there.
Yeah.
Okay. If it is 0, then from that tuple, the color map that we have, from there we are taking. So for 0, whatever value that you have first, you have red comma green, correct? Or green comma red?
Red comma green, sir.
So red comma green, right? So index of red is 0.
Yeah.
So that 0 and that 0 is matched.
Okay.
Okay.
Done, sir. I got understanding of this now.
Okay.
Yes.
Tomorrow we'll look at few more algorithms. We'll talk about few more algorithms.